Hi friends, today let's do the preparation of ketones, which is the individual preparations of only for ketone. In my previous video, we have studied about the common preparations of aldehydes and ketones and also some individual preparations of aldehydes. And today let's do two reactions which is entirely to prepare ketones. That is the first one from acyl chloride or acyl halide. RCOX is commonly called as acyl halide, RCOX, which is to be treated with the R2CD. R2CD is called a dialkyl cadmium. During the reaction, this CD, cadmium, combines with this chlorine and eliminated as CdCl2, cadmium chloride. And the remaining portion of acyl halide is Rc double bond O, that is this Rc double bond O in the product side, which is attached with one alkyl group from dialkyl cadmium, that is this alkyl group. And to balance, we are putting this 2 over here as a coefficient. Let's do an example like C6H5CH3 twice Cd. This is dialkyl cadmium. CH3COCl is acyl halide. So this chlorine and this cadmium gets eliminated as CdCl2. That is the byproduct. Plus main product we will start from acyl chloride, this portion CH3CO. We write CH3CO, that is to be attached with one alkyl group, means one part of this. C6H5CH3 twice is there. C6H5CH2 twice. So that twice in that one part. So one part is we start with the CH2, then C6H5. So it's a ketone. This is a way of preparing. One more example you see. CH3COCl plus C2H5 twice Cd. That is dialkyl cadmium. So first you write this chlorine and the Cd as CdCl2 as byproduct, and the main product is this CH3CO. You write CH3CO combined with the one ethyl group from here, which is A2H5, like this. So CH3CO C2H5 is our main product. Second preparation is from nitriles or from cyanides. A small mechanism is there to see. This is CH3CH2C double bond N. I'll write the general formula. RC triple bond N, that is alkyl cyanide, which is on reaction with, here one example C6H5MgBr. Let's write the common example like RMgX. They are called a Grignard reagent. So during the reaction, C triple bond N, one of the pi bond breaks, means the electrons will be shifting to nitrogen atom. It gives a negative charge and carbon gets a positive charge. And in this case also, alkyl group and magnesium. Magnesium is positive and alkyl group is negative. Negatively charged alkyl groups attached with the carbon of positive charge, and the positively charged magnesium will come with the nitrogen, that is negatively charged. Like this it transfers. Then carbon, alkyl group, then carbon, that carbon with alkyl group R because it's negatively charged. Then triple bond change to double bond. Then that nitrogen gets attached with MgX. This is the intermediate. And when it undergoes hydrolysis, this bond breaks and oxygen will be added over here. So it makes the ketone like this. RCOR. So we get RCOR as a ketone. So without writing the intermediate in the mechanism, simply we can write like this also. You see the example. CH3CH2 C triple bond. It's ethyl or ethyl cyanide or propanitrile. In this CH3MgBr, this CH3 is the alkyl group that you shift to this carbon, and this bond breaks, and here you write oxygen as well. It means CH3, CH2, CO, that carbon with the oxygen, and the same carbon is attached with the CH3. That CH3 comes from alkyl magnesium bromide or Grignard reagent. So without writing the mechanism, simply we can write the reaction in this way. I'll write one more example. You see C6H5 C triple bond N plus C2H5 MgBr. Do the same method. This bond breaks, so that C6H5 C with oxygen and this C2H5 will go and attack with carbon. So it becomes C2H5. C6H5, COC2H5. This is the method to prepare from nitriles. And the last method is Friedel-Crafts acylation. It's an electrophilic substitution reaction. So this is acyl halide. It can be alkyl group or an aryl group. And during the reaction, one of the hydrogen from benzene, any one hydrogen from benzene gets eliminated with this chlorine as HCl. And the remaining portion, for example, if it is RCO, that gets attached with the benzene ring. That is COR or COAR, whatever it is. An example you see, benzene, this hydrogen gets eliminated with this chlorine so that this portion, C2H5CO, gets attached with the benzene ring. So benzene with CO C2H5, which is called acetophenone. Propiophenone because it's C2H5, 3 carbon, propiophenone. Like that, any alkyl group can be used. If it is with the benzene ring with CH3COCl, then the CH3CO is acting as an electrophile so that we get COCH3 substituent in the benzene ring, which is called acetophenone. So these are some of the methods to prepare only ketone. That is, first one is from dialkyl cadmium and acyl halide. Second one is from nitriles. Third is from benzene or substituted benzene. That is by using Friedel-Crafts acylation. So let's do some of the transformation to understand the reagent. You see, it will be from the last video as well. Hexane 1-ol. Hexane 1-ol. Ol is alcohol. To hexanal. Al is aldehyde. Alcohol to aldehyde. PCC. Or we can use CrO3 as an oxidizing agent. Okay. Cyclohexanol. Again, you see the last portion, which is all alcohol. Cyclohexanone, on, ketone. Cyclohexanol is a secondary alcohol that changes to a ketone by using the same oxidizing agent, PCC or CrO3. Now, para-fluorotoluene. Toluene. To para-fluorobenzaldehyde. Toluene to benzaldehyde. In the last video, I was discussing about the preparation. So in that we can use any of the three methods, either by ITAD reaction or by using acetic anhydride and all, or by using side chain chlorination. So chlorination in presence of sunlight followed by hydrolysis, or by using ITAD reaction, any one method. At the nitrile, cyanide to aldehyde. Cyanide to aldehyde either by using Debye-Lech or by using Stephen reaction. Stephen reaction we use stannous chloride and HCl. Any one method can be applied. Now allyl alcohol to propenal, alcohol to aldehyde. Same, chromic oxide or PCC. Now but-2-ene, it represents an alkene. Alkene to ethanal aldehyde. Always alkene to aldehyde is ozonolysis. O3 followed by addition of zinc. So these are some of the common questions which can be asked from the preparation of aldehydes and ketones. So I hope you understood. Thank you all.